Welcome back. Let's finish section 2.1 with this lecture video, part B. All right, we want to use some information about the line to find an equation of a line. And then we want to put that line in slope-intercept form. And slope-intercept form, remember, is y equal mx plus b. So let's see what we've got. We've got a slope, -5, and we have a point, -4, -2. If I'm given a point and the slope, I will go back to my formulas. We're going to use the point slope form, which is y minus y1 equal m times x minus x1. That point is my x1, y1, and that slope is going to go in place for m. So I'll have y minus a -2 equal to my slope times x minus a -4. So really I end up with y plus 2 equal -5 times x plus 4. So that's my equation, but we want it in slope-intercept form. So let's go ahead and change this by distributing the 5, -5x minus 20, and then subtracting my 2. So my equation is minus 5x minus 22. Let me check my work. Slope is -5. X1 is -4, which turns to a +4. Y1 is a -2, +2. Yes, we're good. So let's check out the next one. We've got a slope, so I've got an m, and it's passing through the origin, and the origin is a point. It is 0, 0. So we can use the same format. Y minus y1 equal m times x minus x1. So y minus y1, y minus 0, equal -1/2 times x minus 0. So this falls out to just be y equal -1/2 x. Because if I distribute the -1/2 to the x and to the 0, -1/2 times 0 is just 0. So I'm not going to, I could write it, but we're not. Okay, so we're wanting to find the equation of a line, and it's passing through 2 points. So we didn't see this one earlier, but what can I do with 2 points? Well, with 2 points, I can find my slope. Okay, so let's figure out the slope for this thing. -5 minus a -5 all over 6 minus a -2. So what does the slope come up to be? I think I see a 0 in the numerator and an 8 in the denominator. And remember, it is okay to have 0 in the numerator. So really, we have a slope equals 0. And what do we know about a slope equals 0? It is a horizontal line. And what do horizontal lines look like? They always look like y equal to a constant. So in this case, what is the constant? Well, what's in the y positions? -5. So it's y equal -5. Let's check out the last one. We have this point, and we have not a y-intercept, but an x-intercept. And an x-intercept is a point. That means it's the point -1, 0. A y-intercept would have a 0 in the x position. Okay, I've got 2 points, and what can I find? I can find a slope between 2 points. So I've got 0 minus a -3 over -1 minus 1. Let me check my work. 0 minus a -3, good. -1 minus 1, good. So I get 3 at the top, and -1 minus 1 would be -2 at the bottom. So I get a slope of -3/2. You can put the negative with the 3, with the 2, or in the middle. It doesn't matter. I kind of have a tendency to just put it on the top. So now what can I do to find the equation? Well, let's see. I have a slope, -3/2, and I have a point. And I can choose either one of these 2 points to complete my equation. I'm going to go ahead and use the -1, 0. So let's go y minus y1 equal m times x minus x1. So I end up with y minus 0 equal to my slope, -3/2 times x minus a -1. So what does this equation look like? Y equal -3/2 times my x, and a -3/2 times a +1 would be a -3/2. So y equal -3/2 x minus 3/2. Let's look at an application of slope. So let's read this. The maximum recommended slope of a wheelchair ramp is 1 divided by 12. So there's my slope, rise over run. A business installs a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. The question is the ramp steeper than recommended? So remember, our slope is rise over run. The rise is 22 inches, and I need my run in inches as well to compare. So in order for me to compare, let's go ahead and change 24 feet to inches. So let me pull up my calculator and multiply 24 times 12. I don't want that. I want my calculator. Well, I'm going to have to go to another one. Hold on. So converting 24 feet to inches, I end up with 288 inches. So my rise is 22 inches. My run is 288 inches. That reduces to 11/44, or we can convert it to a decimal by dividing those two out and get 0.0763. So this ramp has a slope of 0.0763. The maximum recommended slope is 1/12. Well, if I looked at 1/12 in terms of a decimal, it is 0.0833. So I'm going to compare the slope of this ramp to the slope that's recommended, and the ramp is not steeper than recommended. It is not a number higher than the 0.08. So 0.08 is what's recommended. This is less than that, so we would be good. Okay, let's check out another application. So we've got an appliance manufacturing company determines that its total cost of producing X units of a blender is given by this equation. So this is our cost equation. We want to interpret the y-intercept and the slope. So right here is my slope, and right here is my y-intercept. So looking at the graph, notice what is mentioned about fixed costs. It says fixed costs are $3,500. So your fixed costs in a cost equation will always be your y-intercept. Those are our fixed costs. The slope, in this case, which is 25, can also be called our marginal costs. Which means if you look at this, this is an increasing line, it's a rising line, so our slope is positive. For every 1 mark we go, 25 would be my rise, and my run would be 1. So every time I go 1 unit to the right, I rise up 25. 1 unit, rise up 25, and so on. So the slope is called marginal costs, and the y-intercept would be called our fixed costs in a cost equation. So let's take a look at this problem. We have a college that purchased exercise equipment worth $12,000 for a new campus fitness center. The equipment has a useful life of 8 years. The salvage value at the end of 8 years is $2,000, and we want $2,000, and we want to write a linear equation that describes the book value of the equipment each year. So each year it's decreasing in value, basically like when you purchase a car. It helps with these problems if you create ordered pairs, and you've got to have the ordered pairs in the correct positions. So in looking at this one, time is going to be in our X position and value is going to be in our Y position, because we want to know at what particular time is, or what is the value at a particular time. So we know when 0 time has passed that the equipment is worth $12,000. But after 8 years has passed, time is equal to 8, the equipment is worth $2,000. So given these two ordered pairs, I can find the slope, and then from there I can find the equation. So let's work on finding the slope. So y2 minus y1 would be 2,000 minus 12,000 over 8 minus 0. So y2 minus y1 over x2 minus x1. So let's see what that comes up to be. 2,000 minus 12,000 would be a negative 10,000. And negative 10,000 will be divided by 8. So let's see what that gives us. Okay, so we get the slope to be negative 1,250. So let's take that and make an equation out of it. We have a slope, and we actually have a y-intercept. Remember the y-intercept, when you let x be 0? This is my y-intercept. So I can use the form y equal mx plus b to find this equation. Y is equal to m, which is a negative 1250, x, got to put that x in. We have to have an x and a y in our equation. So negative 1250x plus b, and the y-intercept is 12,000. So there is the equation that represents basically the depreciation of this equipment. And you can check it out. If I put an 8 in place for x, just pull out the old calculator. Negative 1250 times 8 gives me negative 10,000 plus the 12,000 at the end gives me 2,000. So yes, it works. In 8 years, it's worth $2,000. Last example. So let's wrap this section up with this last example. The sales for Nike were approximately $25.3 billion in 2013 and $27.8 billion in 2014. Using that information, we want to find an equation and then use that equation to predict the sales in 2017. This is similar to the previous problem. To get started, create two ordered pairs. The first ordered pair would be 25.3 billion, 25.3, comma, 2013 for that year. The next ordered pair would be 27.8, comma, 2014 for that year. And whenever you have 2 points, you can always find the slope. So y2 minus y1 over x2 minus x1 gives us a slope of 1 divided by 2.5, which is 0.4. Now we have all the information we need to set up the equation. I chose the first point, but you could choose any one. It'll always work out, whichever point you choose. So for y minus y1, I have y minus 2013 equal to m, which is my slope, times x minus x1, and x1 is 25.3. So I distribute out my 0.4 to both values. So I have 0.4x, 0.4 times 25.3 is 10.12. And that's a subtraction. So 0.04x minus 10.12, and then I took the 2013 and added it to the other side. So that gives me an equation that represents Nike sales as y equals 0.4x plus 2002.88. Now we're not done with this problem because we want to use this model, this equation we came up with, to predict the sales in 2017. So I've got to figure out where to put that 2017 in my equation to find the other value, the actual sales. So take a look at our ordered pairs. The date went into the Y position. So I'm going to plug in the 2017 in place for Y, and I'm going to need to solve this guy for X because X represents the sales. So I'm going to squish that in over here. So I'm going to put 2017 for Y. And now I'm going to have to solve this equation for X. So I'll need to subtract the 2002.88 on the other side. When I do that, let me see what I got on my calculator. I end up with 14.12 on the left equals 0.4x on the right. And to solve for x, I need to divide both sides by 0.4. And again, this is getting kind of squishy, but if I take the 14.12 and divide it by the 0.4, the estimated sales in 2017 for Nike would be, and I'm just going to kind of mark this right here, we get x equal 35.3. So we would estimate Nike sales to be 35.3 in the year 2017. Please email me if you have any questions, but this information will help you complete the homework and web assign.